Hi everyone, I am Harshal from Team MathOratory. Welcome back to our channel. So today again we have our Acad's head, Shomo sir. Hello sir.
Hi, Harshal.
What are we discussing today, sir?
So not only today, going forward, all the time and distance problems that we're going to discuss will be actual CAT problems from recent years. So this is one such example. Let's start. So we have a man traveling by motorboat down a river to his office and back. Great. So whenever you have a motorboat down a river, more often than not, it will be something related to upstream, downstream problems. With the speed of the river unchanged. So as I mentioned, the speed of the river will come in play if you have an upstream, downstream problem. So the speed of the river unchanged. So some different scenario we are getting into. If he doubles the speed of his motorboat, so he is doubling the boat speed. So the river speed is unchanged and the speed of the motorboat is doubled, then the total travel time gets reduced by 75%. So getting reduced by comprehension mistake should not happen. If it is reducing by 75%, the time is becoming 25%. So whatever was the previous time, you're taking 1/4 of that time in this particular scenario. So we are looking for the ratio of the original speed of the motorboat to the speed of the river. So think about this particular question for a minute here. If you think about it, no absolute data has been provided, right? Reduction of 75%, doubling of speed, speed of the river being unchanged. So all our ratio kind of relationship that is provided, as well as the requirement that we have is a ratio thing. Ratio of the original speed of the motorboat to the speed of the river, not the actual speed of the motorboat and the speed of the river. That is anyhow indeterminable. So what we are going to do is to simplify and not take too many variables for this particular question. I'm just going to assume the speed of the river to be 1. You can take anything, 1 kilometer per hour, meter per second, doesn't really matter. So I'm just taking 1 units. And speed of the motorboat, this is what I'm going to assume the variable to be. Let's say S, same unit, both of them. So speed of the river is 1 and speed of the motorboat is S. So for instance, suppose I get, using these numbers, I get S is equal to 5/2, which is none of the options. So just an arbitrary example. So if I get S equal to 5/2, so according to that, our required ratio would be 5/2:1, which is 5:2. So we can always determine the ratio according to this particular data, right? So I'm just going to use the speed of the river, speed of the motorboat rather, as a single variable S. Also, there is something related to distance, right? The distance is unchanged. The time is an outcome. So if you have the speed, you have the distance, the time is outcome. The time reduction, then we can use that accordingly. So again, I'm not going to assume a variable for the distance. If you want, you can, but it really won't make any difference. You can see that variable will cancel out. Now, what I'm going to do is I'm going to consider the distance to be 1 unit again. It really doesn't matter what you assume, just considering the distance to be 1 unit. Now, just for a minute, let me explain why this should work. So think about a scenario, Harshal. Suppose you have a distance of 1 unit, which you move forward on river or whatever, and then come back. If you cover a distance of 2 units with the same speed of travel, the time should be doubled, isn't it?
Right.
So same thing will happen in the second scenario also. So the relationship between the time will not be affected if I consider the distance to be 1 unit or 2 units or 2.5 units for that matter, isn't it?
Correct.
Yeah, so that is why I can actually assume it. So what I'm going to do is, using these numbers, I'm just going to calculate the time. So time for the original scenario. So let us look at the original scenario. So original scenario, he's going to the office and coming back, and he's taking a certain amount of time, right? So one of the motion will be upstream, one of the motion will be downstream. It doesn't matter which one is which one. Both the cases, he covers a distance of 1. Once with an effective speed of S+1. Let's say this is the downstream one. And on another instance with a speed of S-1 effective speed. So this should be the total time. And now in this special scenario, he is doubling the speed of the motorboat. So speed of the motorboat, original one is S, so double would be 2S, right? But the speed of the river is unchanged, so that is still 1. So 1 by 2S plus 1 plus 1 by 2S minus 1. This is the time in the second scenario. Now what do we know? This time, this one, is 1/4 of this time, or this particular time is 4 times of this time. Right? So let us just simplify this now. So in this side, we have taken LCM, S square minus 1, added obviously 2S, S minus 1 plus S plus 1. Yeah, 4 times Again, same thing. In the denominator, we have 4s square minus 1. And again, added, you have 4 times of 4s, right? Now notice another interesting thing, the s gets actually cancelled out, right? So this s gets cancelled out, and also you can cancel out another 2 out here. So we get something like 4s square minus 1 is equal to 8 into s square minus 1, which is 8s square minus 8, right? Or rather 4s square is equal to 7. Just get it this side, get it that side. Or what we get is s square is equal to 7 by 4, implies s is equal to, obviously cannot be negative speed, doesn't make sense. So root over 7 by 2. And remember, our required ratio is s is to 1, which will be basically root over 7 by 2 is to 1, or simply root over 7 is to 2. So that is option B. See, very less calculation, right? If we smartly use the variables.
Right. Ratios are really interesting in this way.
Yeah. And since, as I said, the initial observation, think about the data that is provided. No actual value is provided, right? Remember, in classes, I always used to say that there are 2 types of information that are provided, value-wise. I mean, one is a relationship kind of information, another is actual value kind of information. No actual value has been presented at all, right? Everything is in relationship, doubling the speed, the time reduction by 75%, even the requirement, ratio of the speed of the boat or boat ratio and the speed of the river. So nothing related to actual value it matters in this particular question. All that matters is the relationship. Just maintain that relationship properly and you get the answer. That's it.
Thank you, sir. This was really pretty amazing question, pretty interesting also. So thanks a lot.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.